Hello. So today we are exploring the intriguing processes of nuclear decay, alpha, beta, and gamma decay. So before we start what is alpha decay, beta decay, and gamma decay, let's quickly go through what is a decay. So let's say we have a nucleus of any atom, and we know that nucleus contains some protons and some neutrons. So let's say I'll just draw some random number of protons and some neutrons. So this plus indicates protons and this O or 0 indicates neutrons. Now, what is decay? Nuclear decay is a process by which any unstable nucleus loses energy by emitting radiation. So, let's say this nucleus is unstable. Why is it unstable? So, the most probable reason for this being unstable is it has more energy that it can handle. All the things in the universe usually wants to have lesser energy, or they want to reduce their energy. So if we have some nucleus which is unstable, which has some extra energy, it will try to become stable by losing some energy by emitting radiation, and that this emission can be in the form of particles or electromagnetic waves, leading to more stable nucleus. So what is nuclear decay? A process in which unstable nucleus becomes a stable nucleus by emitting either some particles or electromagnetic waves. So let's start with alpha decay. So in alpha decay, we will have a very heavy and unstable nuclei. Let's take one example. So let's say we will have, let's take the example of uranium. So uranium is heavy and unstable. Not all uranium, but specifically uranium 235, 238. So uranium 238. So the mass number is 238 and the atomic number is 92. So this is a very heavy and unstable nuclei. Now it wants to become stable. How can it become stable? So for understanding that, let's understand why is it unstable. So this uranium nucleus has too many neutrons and too many protons. So if it wants to become stable, it tries to reduce this number of neutrons and protons which are present. So how can you become stable? How can uranium become stable? By emitting some protons and neutrons. So usually what happens is it emits some alpha particles. What are alpha particles? Simply we can say it emits four nucleons, that is two neutrons and two protons. So it would emit alpha particle, and if once it emits this, it would become thorium, because the mass number would change and the atomic number would change. Obviously uranium becomes thorium because the atomic number has changed from 92 to 90. This mass number is not necessarily the reason behind uranium changing into thorium. The reason is the atomic number, that is the number of protons, has changed. So what has happened is uranium has given out some alpha particles, that is two neutrons and two protons, and it has converted into some other element which is thorium. Why it has happened? So that we get some nucleus which is more stable than the previous one. So this is unstable, this is unstable, and this is more stable. I would not say this is not unstable, but this is more stable. Something can happen after this also. It might happen that this is still not fully stable, or the amount of stability which is required. So it can happen that this can also emit some, it can also decay into some other smaller nuclei. So in alpha decay, the nuclei is heavy and unstable. So this is the reason for alpha decay, and we have heavy and unstable nuclei. Now let me clarify this again. Why do why does it happen? Because there are a lot of protons which are present in the nucleus, and we know that the protons will repel each other, and because of this the stability would reduce. And so if the if the alpha particles that are neutrons and protons are emitted, the size of the nucleus can reduce. Now let's discuss beta decay. It comes in two forms. One is beta minus, and one is beta plus. So I'll just write some examples so that I can explain clearly. So for beta minus, I'm going to take the example of carbon 14 decay. So carbon 14 decays into nitrogen, and there would be some beta minus particle, beta decay, and then there would be something called a neutrino, anti-neutrino in this case. We'll discuss this. And then there is this beta plus. So in beta plus, let's take the example of fluorine. Fluorine. It would get converted into oxygen, and there would be some beta positive decay, and then again some neutrino would also be emitted. We'll discuss what is neutrino. So these two things happen. In one is beta minus decay and one is beta plus decay. So why does beta decay happens? So beta decay occurs when a nucleus has an imbalance in protons and neutrons. If there are too many neutrons, beta minus decay will happen. If there are too many protons, then beta plus decay will happen. So in this case, we are trying to reduce the number of neutrons. And in this case, we are trying to reduce the number of protons. So usually what happens is, if the number of neutrons and protons is, let's say, somewhat equal, and or if there is not much mismatch in the number of neutrons and protons, the nucleus tends to be stable. But if there is some mismatch, so for example in this case there are 6 protons and 8 neutrons in this case. Now let me explain more about this. How is the number of neutrons changing, and how is the number of protons changing? So let's say we have extra neutron. We have extra neutron. Now we can say that neutron is composed of something positive and something negative, adding up to 0. Now we know that we have something positive which we call as proton, and something negative which we call as electron. So if the number of neutrons is more, what can happen is this neutron can convert into a proton by emitting a beta particle or something called an electron. So here what is happening is the number of protons, it has increased from 6 to 7. The mass number remains same because instead of one neutron we have now one extra proton. So there were 6 plus 8, 6 protons, 8 neutrons. Now there are 7 protons and 7 neutrons because one neutron has reduced but one proton has increased. So mass number remains the same, but the atomic number has changed. And what has been released? Electron or beta particles. And in this process, some neutrino, anti-neutrino particles are also released. This particular particle can be avoided for now for explanation, otherwise it can get complicated. But let's just assume this is some sort of an energy which is released. Now what will happen if we have an extra proton? So we can assume that this proton has some overall positive charge. So what the proton does is it gets converted into a neutron. But since there is this positive charge, so there is one particle, positive particle, which is released. So most of the mass of the proton is here only, and there is some very light particle like electron, but positively charged, which is released, and we say this is as positive electron or positron. So to summarize, if there are extra neutrons, it will get converted to proton and electron. If there are extra protons, it will get converted to neutron and positron, and the number of protons and the neutrons would become proper, which is required. Now let's come to gamma decay. So gamma decay is essentially the release of electromagnetic radiation. Gamma rays are electromagnetic radiations. So it is very simple. So let's say we have this example of cobalt. What would happen is this cobalt would get converted to nickel by beta negative emission, but it would have some extra energy. So what can happen is this extra energy of nickel, it can be emitted in the form of electromagnetic radiation, and this gives rise to gamma decay. So why does gamma decay happens? It happens if the nucleus is in the excited state. Emitting gamma rays allows it to shed some extra energy without altering the protons or neutron number and reducing its energy. So in this case, there would not be any change in the number of electrons, number of protons, number of neutrons, nothing, but there would be some change in the energy. Energy would reduce. So to summarize, alpha decay occurs in heavy nuclei to reduce proton count. Beta decay balances the number of protons and neutrons, and gamma decay releases excess energy from an excited nucleus. Each type plays a vital role in the stability and transformation of atoms.